Okay, on to our next lesson. I'm pretty sure I'm going to start every video with okay. That's just how things work. Last video, you probably noticed I've got all my kids' toys behind me. This is what happens when you have a dad of 3 kids under 6. This is just what happens. So you can take a look. Yes, we got lots of fun toys. That's just the way it is. This is the best lighting. Okay, on to the next section. This is algebra and trigonometry. I think this one might be a little bit shorter of a video, but the material for algebra is more complicated than last time. So there's less information to teach, more just showing examples today. So what are the purposes? We've got to review algebra, to review trig. These are what our purposes are. Pretty straightforward. Nothing new today. I'll review. I said last lesson, all the material that you're learning in these 2 lessons, you need to know it. If you don't know it, you cannot do physics. That might seem like an over-exaggeration, but it's true. If you can't do algebra, you really cannot do equations. So you need to know this stuff. If this is tricky, that's unfortunate. This is going to be the whole year. So work hard now, it'll pay off later. The key to doing algebra is just remembering your inverse operations. So knowing what cancels out with what. For example, timesing is the inverse of dividing, and dividing is the inverse of timesing. So if you have something that's times, to get rid of it, you divide. If you have something added, you subtract. If you have something squared, you take the square root. You just need to know what the inverse operations are to be able to do this. So let's try and solve this one. So we're going to take the equation f equals ma and solve for m. This is an equation we're going to use in dynamics. You don't need to necessarily know what the variables are at this point, just need to know algebra. So in this question, we're trying to get m by itself. So we need to get rid of a. If you look at this equation, it's m times a. The inverse of multiplying is going to be divide. So we're going to divide both sides of this equation by a. That gives us the equation f over a equals m. And we know that we've solved it if we have the unknown variable, or what we're trying to solve for, is by itself, and there is no m on the other side of the equation. If we have 2 m's, that's a problem. So whatever we're trying to solve for, make sure there's 1, and it's by itself on one side. All right, let's try this other example. We want to solve for t in the equation v equals d over t. Which is speed equals distance over time, or velocity equals displacement over time. We'll get to that in kinematics. These are all equations we're going to be using. In this case, we've got a t in the denominator. This is a no-go. We don't want what we're solving for to be in the denominator. So first, I want to get the t out of the denominator. So it's d divided by t. To get rid of dividing, we need to times. So we're going to times t onto the right-hand side here to get rid of t. We can't just do that. Have to do it on both sides of the equation, which gives us v times t equals d. Now, we haven't solved for t yet because it's not by itself. We have v times t. So again, the inverse of multiplying is going to be dividing. So we're going to divide both sides by v, which gives us the equation t equals d over v. T is by itself. There's no t on the other side. We've solved it. There's algebra. Let's try it for something a little bit more complicated. So in this case, we've got multiple operations. So first things first, we want to get rid of the v naught squared. This is just v initial. That's what that stands for. The reason we get rid of that first is if we were to actually plug in numbers and solve it, we would take a, which is what we're solving for, and times by 2d first. So I don't want to get rid of the 2d yet. Technically, you could divide by 2d of everything, but most students get that confused. So I usually teach get rid of v naught squared first. So this is added. We do the inverse, which is subtracting. Subtract from the right, subtracted from the left. We get this equation. So now we're not quite done yet. We still have 2 times a and d times a. Since those are both multiplied, we can get rid of them in the same step. Divide by both of those because that's the inverse. And here's our equation. Again, a is by itself. The rest is not a, so we've solved that. The next thing we want to do with this is go one step further. So not just do the algebra, we actually want to plug in numbers. That's going to be our next thing we do here, solving with some actual numbers in there. Let's take what we did in example 1, the same equation. We want to solve for m. And now I'm going to tell you that F equals 20 newtons and A equals 2 meters per second squared. Again, don't worry about forces and acceleration and the units and all that. I won't be picky about units this time, But I'm just showing you this so that you can get comfortable with what the units actually will be, but I'm not going to mark that on the test, at least not this time. So we're going to solve like example 1. Again, we have an equation. Get rid of a from both sides. We get this equation. From here, we're going to substitute numbers. We've got that f equals 20, so plug in 20 in the numerator. A equals 2, plug that in the denominator. Solve that. Mass is 10 kilograms. That's how you do it with numerical substitution. Again, I knew that this equation mass is kilograms, so that's why I put it, but don't worry so much about that yet. Let's try with this long, complicated one. I'll review how to solve this again very quickly. So we're going to solve it like we did in example 3. It's the same equation. Start with this. We want to get rid of v naught squared first. Subtract that from both sides. We get this equation. We want to divide by 2d to get the a by itself, like so. Here's our equation. Now we're going to substitute some numbers. So I switched the equation around here. Don't get confused by that. I just put a on the left, but it doesn't matter which order you put that. And we plugged in some numbers. So v by itself is 5, v naught is 0, d is 15, so I just plugged in those numbers. On a test, if you put in the numbers like this and then just put the answer, that's fine. I'm going to show you the steps just so you don't get too confused in my methods. But if you went straight from a equals 5 squared minus 0 squared divided by 2 times 15, straight to 8.33, that's fine. I just wanted to show you the steps so you can see where those numbers came from. And again, don't worry about the units yet. I'm not going to be picky about that just now. Okay, that was it for algebra. Now we're going to move on to trig. Trig is pretty straightforward. So a few reminders with this. So first of all, Pythagorean theorem. If you have a triangle like this, let's label the sides. So A, B, and C. It doesn't matter which one is A, which is B. All that matters is C is the longest side, your hypotenuse. This is your equation. A squared plus B squared equals C squared. That's Pythagoras. And then we have trig relationships. So here is our triangle, same as before. Let's put theta on the bottom right. So hypotenuse is always the longest side. We want to know what's the adjacent and the opposite. So taking a look at our angle, theta there, if we look at the opposite side, it's on the opposite side from the angle. That's how you know it's opposite. Adjacent just means beside. So this is your adjacent one. So as long as you have your hypotenuse as the longest one, the other two are not too bad. It just depends on which angle you're looking at. If you recall SOHCAHTOA, these are the 3 equations for sine, cosine, tangent. You need to know these. They are not going to be on the formula sheet. But again, you've used this so much that you should hopefully understand those. So sine is sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. These 4 equations, I'm really hoping you have those memorized because I will not give you those values. Let's actually solve a triangle. So I give you these 2 sides, the hypotenuse and one of the other sides. First, let's solve for A. I'm going to label it A. Again, I could have called it B. It doesn't really matter. We're going to use Pythagoras, plug in some numbers. I'm going to show you some algebraic steps here so you can see my process. But really, I don't need every single step from this. I need, what's the equation? A squared plus B squared equals C squared. That's always a mark, is showing the original equation. Show me that you're plugging in numbers, and then give me a step in between before you get to the final answer. Because the 2 sides are given in centimeters, I put the answer in centimeters, again, making sure that you put some units in there. So solving a triangle doesn't just mean get the other side. I need all the angles. The bottom left angle is always 90 degrees. You don't need to show me that, but we need to solve for the other one. So I'm going to call the bottom right here theta 1. I have all 3 sides, so it doesn't matter if I use sine, cosine, tangent. I picked cosine because those were the given values. Plug in numbers. In order to solve for an angle, we're going to use the shift cosine on your calculator. And this gives you this degree. We're always going to use degrees in our answers here. Don't use radians, if you know what radians are. Now for the last angle, let's call this theta 2. The nice thing about triangles is all angles add up to 180. So if I go 180 minus the other 2 angles, we get our answer. There we go. We've got all of our angles, all the sides with our triangle. It's solved. That's all you need to do. There we go. That's the end of this unit. It's just 2 quick sections, but very, very important. You need to know these units because the rest of physics is really going to be difficult. So take this time, make sure you know how to do the conversion, make sure you know scientific notation, make sure you know how to do your algebra. Don't just use shift solve on your calculator because you will not get marks for that. And make sure that you know trig. Sometimes you'll need to be able to use trig in an equation, especially once we get into forces and energy. So there you go. That's the end of this unit. Okay, here is the next clip for you guys. This one's from the movie Interstellar. If you haven't seen it, I highly recommend it. Essentially what's happening in this one, there's some astronauts. One of them's trying to dock with the space station, but is not lined up properly with the landing area. So you'll see what happens. So watch this video, see if you think the physics in this is true or not. Okay, so there is the clip. I'll give you a short pause here. You can try and think if that was good physics or not. Hopefully you were thinking about it in the middle of it. Yeah, so if you didn't figure it out already, this one is good physics. That's why I recommended it. Obviously, if I'm a physics teacher and recommending something that's not good physics, that's not a good teacher. If I'm recommending bad physics, although I probably would, because there are many things I'd recommend. Okay, so let's go through this clip and let me just explain a few things, how this is actually a great way for you to see some physics. I just need to get to the right spot. Okay, so obviously there's some cabin pressure. This is what causes things to go off. And the cool part with this, if you go back and watch the original clip, they had no sound at that explosion part. And that's actually what happens in space. There's no particles, so you don't actually hear sound in space. And as that explosion happens, it causes this space station to start to rotate. So once we get into momentum, you'll see how that works. There's an explosion, there's momentum, and with that momentum, it causes the space station to start spinning. And it spins at a constant rate because there's no additional forces causing it to push or pull. The particles are floating around, which is exactly what happens in space, and they would eventually fall to the planet because it's got gravity. But they are floating around like that, which is what's going to happen. Let's skip forward a little bit. Okay, so because of the gravity, that's why the space station is going further towards the planet. That's why there's some endangerment for that. And they're calculating what the rotation of the space station is so that they can dock properly. So as you can see from this angle, from a reference frame being on the space station, you could see that it looks like the spacecraft is actually the one that's moving when really it's not. Interesting thing about reference frames. So they do some fancy math. They calculate how many RPMs they're doing, rotations per minute, and that's why you see the space station rotating. Okay, and so now they're going to apply some angular momentum. This is what they're doing when they shoot out that air, and that is why their space station starts to look like this. You've got some sideways motion here. That's what aligns them up. And as you can see, it puts a lot of pressure on the astronauts, which is actually what happens. If you see any training videos for fighter pilots, this is what they do. They go through high rotations because they're experiencing here higher gravity. So this astronaut actually blacks out here. You can see that because she's no longer in control of her arm. And that's why it goes up and it's just floating around there. Let's skip a little bit further ahead. So when they manage to dock, that's great. And now they want to slow down the rotation of the space station. So they're going to apply, or they're going to shoot out some air, as you can see here. It's happening over here, to slow down the rotation, and then apply the main engines to try and push the big space station up and out of this decaying orbit. So make sure it doesn't fall towards the planet. So there you go. That is the physics for this one. There's some other great physics in this video, or in this movie if you ever want to watch it. Like I said, there's some great stuff in there. Some parts that are a little bit confusing, but it's good. There you go. I will see you in the next video.